This is the Gleason map, and this is the map that the flat earthers claim to be the map of the flat earth. And I want to point out a couple of things. Let's start with this section right here. We are going to look at this area right here. Here to there. These two areas look like you should be able to get in a boat and just sail across from the end of Alaska to the end of Russia. It also looks like you should be able to fly from Alaska and go over Russia. But can that be done? Let's look. When we look at flights from Anchorage, Alaska to Moscow, Russia, look where it stops and look at the time. Let's look at this. It is going to stop. Let's see, is that Denver? It's going to depart September 7th at 11:45 p.m. and arrive the next day at 1:45 p.m. And it looks like that might mean you gain 3 hours. But the flight appears to be 51 hours long. The returning flight is 38 hours long. Right here. 38 hours. So, if the Gleason map is correct, then why would a flight from Alaska to Russia take 38 hours? So my question is, if this is the correct map, then why does the flight go from here to Denver and then around this way to get to Russia? Why does it do that instead of flying from here and going this way into Russia? If this map is correct, why do flights take that route? Why don't any flights fly west out of Alaska? Unless it's just to fly this way and then go around. Now look at this map and think of the flight. Alaska is all the way to the west. Furthest west you can go. And then if you fly east, look where Russia is. It's on the opposite side. The opposite side of the Earth. So doesn't it make more sense for a flight that takes 38 hours to be in these two locations as opposed to the other two locations on the Gleason map? Take a look at this map again. If you go above Alaska and you go above Canada, there is the Arctic Circle. And all above this area where the Arctic Ocean is, it's icy. It's ice further than you can see with your eyes. If you could go as far as you could possibly go above Alaska, above Canada, these areas, Greenland, keep going, keep going, keep going up. You see this Arctic Ocean, those letters? Well, if you can get there through the icy waters, you're done. You can't go any further. So something else to notice about this map is the way the lines go across the map, and notice how they stretch out, they get wider. And then look at the shape of Australia. And what you need to realize when you look at these lines, there is no perfect square on this map. And the reason why is because this is a projection of a globe, looking at it from the top of the globe down. So if I was staring at the top of the globe, you have to picture this as a ball and stretched around a ball. So these lines represent curvature. And that is why a lot of the measurements, when you're looking at the degrees, the parallels and stuff, it may work on this map. And I know some of you have said it works perfectly. Like, let's see. Where is the 33rd parallel? Anyway, it's based on curvature. It's based on the globe, the spinning ball. And that is why they're all stretched out. And if you look at the way they're stretched out, it's exactly how you would draw the lines if you were accounting for a curvature. So this map has north in the center, and then they say this is Antarctica going all the way around. The outside edges is Antarctica. They say that they just flatten the ball this way. And then, so this is all south, going all the way around. And then, when you want to travel west and east, it's basically going in a circular direction. Now, if you ever look at a compass, which is basically a representation of the flat earth, a compass has a dome. There's usually a star in the center that represents the North Star, which is navigational. And we have north, south, west, and east, like this. And you can navigate using the North Star, which I've talked about in another video. But if you look at these directions, this map makes no sense. It makes it because this isn't north. This is what they say is the south. They say this is north. This map makes no sense when it comes to a directional compass. A compass you should be able to lay right on top of the map and it should be a match. Now take a look at this map. Look where north is, south, west, and east. And look, here we have all of the countries where they belong. This is the flat earth map right here. This is the accurate flat earth. And what's in the center is Jerusalem and the pyramid. The pyramids are the belly button of the earth. Dead center of the earth. This is what the map looks like, and we have a dome over our heads, and we are surrounded by ice. Because if you travel north as far as you can go, you run into ice. If you travel south as far as you can go, you run into ice. West and east, You cannot travel west all the way to an ice wall because you'll run out of gas first. Same thing with the east. I've looked it up, the furthest place you can go west and east, and they're small little islands, tiny little islands, and you better land there because if you go any further, you're gonna run out of fuel.